Yes. So that's pretty straightforward. I can see what X is going between, and I can see what Y is going between. So I kind of know the amplitude of both of those. So that's the easy part. The hard part is figuring out these numbers, right? And they kind of relate to how many, it's not easy to see, but it kind of relates to how many, say it, Jeff, cycles fit within each, but it's yeah. The nice thing is you're supposed to use your graphing calculator to help you. So what do? You take a guess of what B and D are, and you see what it, and then put it in your calculator, see what it looks like, and then keep trying to change B and D until it looks like this. Yes, maybe? Is that all right?
Yes, that makes a little bit more sense. Thank you.
People kind of skip over this. You are completely allowed to use your graphing calculator while you're doing this. You're not supposed to figure this all out completely on your own. Okay. Anything else, guys? Okay. So let's see, where am I at here? Here we go. I want to show you, there's something I unlocked that I actually forgot I had up here, to be honest, but this is kind of useful. If you go to Canvas and go to Unit 11, well, shit and a half. Here we go. Okay. Unit 11, you'll see System of Three Equations handout. So if you need any help with that, I'm hoping it's relatively straightforward, but I've got a fully worked out and explained problem here with all the steps you want to go through. Right? Okay. So that's there. I think I still need to, I did put up here the practice quiz for the next quiz. Here it is, practice quiz 11. So that's up there for you. Okay. Oh, tired. All right, guys. So if there's no other questions, we're just going to get right into the next stuff. Because we're crazy people. Okay. All right. So let's see. So we did 11.2 last time. We don't do 11.1. That's a review of 2 equations and 2 unknowns. Who cares? You guys can do that. 11.2 is about 3 variables and 3 unknowns and 3 equations, 3 unknowns. And normally people haven't done as much with that. And then 11.3 we skip. Although, to be honest, real quick, I just want to show you one thing from 11.3. 11.3 is neat because, and this kind of makes sense. If somebody help me out again, if I graph a system of 2 equations, where's the answer?
A point crossed.
Yeah, where the lines meet, that point is the answer, right? And then I talked yesterday about, I took my camera and I walked over to the corner, said system of 3 unknowns with 3 equations. Each equation is a plane. So it's still the point where all 3 planes intersect. Everybody with me so far? You guys all right? And what 11.3 does, and I know it's not in our curriculum and I don't care, 11.3 says I can have nonlinear equations. This is really nonlinear. This is not even circle, but stay with me. Like if I had a parabola and a circle, couldn't there be 2 solutions to that system of nonlinear equations, right? There and there, right? Or there could be no solutions. I could have a circle with a parabola and it just doesn't intersect at all, right? No. You're weird as shit, Jeff. All right, and in calculus, you could actually see a parabola, up parabola, and a down parabola, right? And in this case, you might be interested in, you'll be able to figure out the area that's in between the 2 functions. That'll be calculus. Okay, so let me stop sharing this. me stop that. Just go away. So the next thing we're going to do is desperately nifty. All right. And I know I say something like that a lot. Oh man, I don't know if you guys even believe me anymore when I say things like that. This really is, all right. I think I said the same thing about something else recently, but this is really one of my favorite things in pre-calculus. Let me see, which I don't know how that makes you feel. I don't know if that makes you feel good or worried or what. All right, here we go. So let's do this. Watch this. This is kind of cool. Oh, let me see. I think I had a, well, no, I'm going to use that example. That's right. I'm going to use that example later. Maybe, yeah, okay. You guys, please, I'm going to put something up here and I want you to simplify it. Please. Let's see. Please just simplify that. Sorry. All right, this shouldn't take forever, right? There's kind of a shortcut. Let me show you guys something. If I'm combining two fractions and the bottoms, stay with me now. Stay with me now. Watch this. If I'm combining two fractions and the bottoms are something called relatively prime, neither one has parts of the other one, right? The shortcut is you sort of cross multiply. That's 21 plus 8 divided by 4 times 7. I don't know if you guys have ever seen that before or thought about that. That's a nice shortcut for when the bottoms are relatively prime. So I can do the same kind of thing here, but if you want to see the whole thing, this guy, of course, needs what? What does this guy need?
X plus 1.
He needs an x plus 1. This guy needs x minus 2. So we get 3x plus 2x is 5x. 3 minus 4 is minus 1 over x plus 1, x minus 2. Cool. And then, of course, that won't factor, so I can just go ahead and x squared minus x minus 2. Okay. Wah! What we're about to get into is doing exactly what we just did backwards. What we're about to get into is if somebody gave me this fraction, can we break it up into its parts? Does everybody understand the idea? Oh, I missed the wow. Amanda, what was the wow for? Oh, well, all right, I don't know. Does everybody understand what the idea behind the process is going to be? It's if I'm given this, oh, the cross multiplying, yeah, this is a cool trick. And again, it really, really only works well if these two are relatively prime. Because again, I mean, so look, doesn't he need an x plus 1? So doesn't it look like that just came up here? Doesn't he need an x minus 2? Doesn't look like that just came up here? And the bottom is the 2 multiplied. Okay. There's a ton of stuff like that. And you need to start making your own shortcut kind of stuff like that, right? Okay. Now, again, we will get a problem like this, and our objective is to break it into parts. So this is called partial fractions, breaking fractions up into their parts. All right. So for example, if I got this here, what do you got, Jeff? 4x minus 5 over x squared minus 3x minus 4. Sure, I like it. What do you think is a good first step, considering what went into what we just did?
Factor the bottom.
Yeah, if I factor the bottom, I know the parts that this must have come from. So of course, how do you factor the bottom here?
Minus 4 plus 1.
Now watch this. This is kind of cool. This is so cool. This is so freaking cool. This must have come from two fractions adding together, right? What would the bottom of one of the fractions have been? Somebody else. Sorry, Rio. You can't get all the answers. What would the bottom of the fractions have been? Each one separately. Yeah, good. X minus 4. And of course, x plus 1. And on top is some number I don't know on that one, plus some number I don't know on that one. I like that. Okay, now, right, this is sort of like, this is kind of undoing what we did. The end result must have come from two separate fractions with those parts in them. Oh, that's right. There was something. All right, hold that thought. What is this? Oh, look at that. That's from, oh yeah, remember that? All right, sorry. Hold that thought for a second, guys. Find, dadgummit. I had figured out earlier that I wanted to do this first. Scheiße. Watch. Watch, stay with me. Real quick, this is a little side note. This is such a beautiful thing. Can somebody tell me, if this is a true equation, what must a plus b be? If this equation is true, what must a plus b be? What must it equal? A plus b must equal 4, correct? That's the only way this could be a true equation. And of course, what must b be? What must, yeah, b's gotta be 3. So b is 3, a plus b is 4. So a plus 3 is 4, so therefore a is 1. All right, so that's a weird little sidetrack, isn't it? But somehow that relates to what we're about to do. This procedure we just used is called equating coefficients. Of course it is. What's the coefficient of x here? 4. What's the coefficient of x here? A plus b. Therefore, a plus b must be 4. Okay. Is everybody with me so far? Anybody lost? Does that make sense? Is that too easy to believe? Is that weird as shit? Can I get a reaction of some kind? Too easy makes sense. Okay, so watch what I'm gonna do next. I'm gonna multiply both sides by these. And I'm gonna do this in more steps than I normally would. So I'm gonna multiply both steps by x minus 4, x plus 1. X minus 4, x plus 1. X minus 4, x plus 1. So then what happens here? I get 4x minus 5 equals a times, what happens here? x plus 1, plus b times bam, bam, x minus 4. Kind of did that a little too much. All right. Is everybody okay with what I just did? I have an equation that I'm assuming is true. So we know it's true. It's true for some A and B. We just don't know what they are yet. Now, let's go with me. There's a really cool second way to do this. I'm going to show you in a minute. We're going to do the first way, which is the textbook way, which is the normal way. Everybody does this shit. And then I'm going to show you a cool freaking way. So just deal with the boring ass way. So here's the boring ass way, the bay. Jeff, the Bob. Okay. 4x minus 5. I'm just going to distribute, right? Can you guys see it's going to be ax plus bx? So it's going to be a plus b x. Is that cool? Right? Ax plus bx. So it's going to be a plus bx. And then what do I get at the end here? I get a minus 4b. So somebody please tell me, what is a plus b? Gotta be. What's a plus b gotta be? What is a plus b gotta be? A plus b. A plus b.
4.
4. What is a minus 4b gotta be? So that is 4. So that must be -5, exactly. All right, is anybody lost, or do you not trust it because it seems too easy? Or are you saying, don't say it's too easy because I don't have a freaking clue what you're doing? You jackass, don't call it easy. Which camp are you guys in? Are you guys going to tell me? Don't tell him anything. Don't give him anything to work with. Oh shit. All right. Was anybody not cool with this? This was the time to speak up. So a plus b had to be 4 because that's what's in front of x. B had to be 3 because that's what after the minus sign, right? Is everybody cool with what we did here? Doesn't b have to be 3 because it's the thing that's by itself? They're both constants. Doesn't a plus b have to be 4 so that this is 4x? So you're really thinking, how do I make this 4x minus 3? Well, if this is 4, bam. And this is 3, bam. And then you have a system of equations, which is why it makes sense. It's right now because we were just talking about systems of equations, correct? Okay, so coming back to here. So all I did here, right at this step right here. Let me make sure. Maybe I did one step too quickly. This is 4x minus 5 equals ax plus a. Is that cool? Bam, bam. Plus bx, bam, minus 4b. All right. So I kind of skipped this step earlier. So then I can collect my stuff together. 4 is in front of x here, and -5 is by itself. What's in front of x is a plus b. And then what's by itself is plus a minus 4b. So again, what must a plus b be to make this true? We don't have to go through it all. Does everybody see this now? Yeah, this has got to be 4 to make this true. And of course, this has to be -5, right? see if I can do this. Sorry. So now this is just a system of equations. Forget all this shit right now. This is a little tiny system of equations. Do it. Solve this system of equations. Do it. Close. Yes, they're not going to be pretty, but too bad for you. There's a few different ways you can do this. Oh no. The way I would do this real quick is I would multiply through this one by -1. Then I can add these together. So I know B is 9/5. So then A has to be 4 minus 9/5 is 20/5 minus 9/5 is 11/5, I believe. Is that right? Normalish algebra, like, bam, this is powerful. Holy shit. I gotta stop taking hits. That's too many. Okay. So what the shit did we just figure out, Jeff? What did we just? Well, I know A is 11/5, correct? So then isn't this equal to 11/5 x minus 4 plus? So pretty cool what just happened. A is 11/5. So let me put 11/5 where A is. And there's x minus 4 plus, and what's B? 9/5. So it'll be 9/5 x plus 1. So this to me is one of the coolest things because it feels simple, it kind of is complex, but it's doing something that at the time, I was like, how the shit are we gonna like break this up? How are we gonna do that? And this is such a interesting, simple, but still a little weird kind of way to do it. So let's do this. Somebody, any questions from this part? So what I want to do is I'm going to erase this right here. I'm going to show you a different way to do this that doesn't always work, but when it works, it's freaking cool as shit. All right, so this is the textbook way to do this. Do this, equate coefficients, set up a system of equations. Can you guys understand that there will become times when there's more than just A and B? You might have A and B and C and D and E and F. G. I will wait, yes.
I understand how to do them like that way and then also how you showed on the back, but why wouldn't you be able to solve that how you did on the back?
No, so, all right. Let me see. Is somebody still copying this down? I think they are. You good? Okay. This is what we did. I really want you to understand whatever was in front of X, we made it equal to whatever's in front of X, correct?
Yes.
Why is this one simpler though? Because there was only one thing that was out by itself. So B directly equaled 3. In this one, what's out by itself? Oh shit, here, this part. So that has to equal -5.
Okay. Yeah.
And of course, here just in case you missed it, I changed the signs so the A's would die, blah, blah, blah.
Okay, that makes sense. Thank you.
I like it. All right, so what I'm going to do, I'm going to erase this here. You ready? I'm going to erase all of this here. You ready? Here it goes. Okay. Bye. Now, you do not have to do this way if you don't want to, especially because it doesn't always work. What I mean by it doesn't always work, it'll be very obvious when it won't work. Do you understand what I mean? It's not going to be a situation where like you do what I'm about to do, you get an answer and it's not true. Screw you. No, it'll be really obvious that it will not work. So you'll have to do the ABC kind of, the system of equations. Watch this. Can somebody tell me, in this expression, what can x be? Well, this is a little weird. In this expression, x can be anything, of course, except for 4, -1. But in this expression, here's what's neat. X can be anything. What's special if I let x equal -1? Why is that interesting to pick that value? If I let x equal -1, what happens to this piece?
0.
This piece becomes 0. Does everybody see that? So if x is -1, I get -4 minus 5, I get -9 equals a times 0 plus b times -5. So we get -9 equals 0, -5b. And I get the same frick. Do you guys understand what didn't we? Isn't that the answer we got? Isn't that the answer we got? Isn't it? All right. So what other value would I want to let x be? I would want to let x be 4, wouldn't I? Right? So let me see if I can squeeze. If I let x equal 4, I'm going to get 16 minus 5 is 11. Oh, interesting. Equals a times 4 plus 1 equals 5a, and of course plus 0. So a is 11/5. Isn't that what we got? Isn't that? Wasn't that a little quicker? Wasn't that a little quicker? Ooh, that's nice. When will this not work, Jeff? Well, on the problems that are a little bit weirder. That's when it won't work. So let me do, all right. And I do have a handout. I just haven't made it active yet. There's a handout that's going to cover every damn thing I talk about right now, okay? So don't freak out. It's going to get a little freaky. The thing about this method, this kind of method is used so much in mathematics. You assume what the answer looks like. I'm assuming the answer looks like this. And then using that assumption, I work with it to figure out the parts that I don't know. It's so neat. And of course, you have to have ways to determine what should it look like, right? Because if you leave something out here, this is never going to work. So I'm going to erase all this. You ready? All right, here it goes. Oh, you like it better? Okay. And again, it's really, 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 really awesome when it works. And when it doesn't work, it's just kind of sad. So let me do this. Let me show you something. Here we go. What is different about, all right, well, there's two things that are different about this situation here. You can do it, Jeff. There it is. All right, what are two things that are different about this situation than the problem we just did? All right, what's the most obvious difference between this problem and the problem we just did? What was the degree of the top in the problem we just did? Didn't the problem we just did look more like that? Yes? With different numbers? Are you guys all with me out there? All right. Wasn't the, all right. Does anyone see what I'm talking about at the moment?
Yes.
Okay, so if the degree on the top and the bottom are the same, this isn't truly a fraction in the real sense. I can divide this and get a whole number part out of the way. So partial fractions only speak to situations where the top degree is less than the bottom degree. Let me say that again. Partial fractions only have methods that work with fractions where the top degree is less than the bottom, because if that isn't true, the first thing I do is long division. Yay, long division. We've missed that, Jeff. We love the hell out of that stupid ass thing. Let's do it. Okay, so how do I long divide this? Probably something like this. I'm just going to do it real quick. I don't know if you guys hate this, if this is traumatic for you. So this is 1. That was hard. So x squared minus 2x minus 3. Change the signs. 5x minus 7. So this is 5x minus 7 over x squared minus 2x minus 3. So see how I've already got a piece of it figured out, don't I? And then I've got to figure this part out. Yes, maybe yes. Okay. So now the problem becomes, can somebody see how to factor the bottom here real quick? That's easy, right? How do I factor the bottom of that?
Minus 3 on the 1.
Yeah. So what's going to go over here? So it's going to be
X minus 3.
Yeah, so it's going to have an x minus 3, and there's an unknown thing on the top. X plus 1, and there's an unknown thing on the top. Okay, I like it. Just in case. There are so many reasons why it doesn't matter which one of these is with B and with A and which one comes first. It's addition. Who gives a shit, right? Okay, I like it. Just in case. Somebody's like, oh no, which way? Now let's see if you guys can handle this next shortcut. If I multiply by these, doesn't each one cancel what's already there and pick up the other guy? Does that make sense? If I multiply by this, the x minus 3s will cancel. It'll pick up the other guy. If I multiply this one, the x plus 1s will cancel. B is going to pick up the other guy. Does that make? That's a really quick little shortcut we can do. Why write all the shit when I know what's going to happen? No, yes. If you don't like what I just did, you can write all the shit and see it happen. All right. Go ahead and finish that out your favorite way. I got to step aside for a second. Where am I at? Here I am.
Can I ask you a question? Professor?
Yes, what's up?
What does magnitude mean?
What does magnitude mean?
Yeah.
From has nothing to do with this, right? I mean,
Yeah, just asking.
oh, it's the length. So like I said the other day, instead of calling the vector's length a length, we call it a magnitude.
Oh, okay.
Yeah. All right. So I'm going to kind of do it both ways a little quickly. So one way, it's pretty cool, ax plus bx. So a plus b has to be 5, and a minus 3b has to be -7. I have no idea how many are doing it this way. Then I would do the same thing I did earlier. It's pretty cool with what I just wrote down. Can you guys see that? I would get ax and bx. That's a plus bx. So it's got a plus b must be 5. And a minus 3b has to be -7. And if I change all the signs here, I can add these together. So b is 3, and a plus b is 5, so a must be 2. Now, if you did it the other way, real quick, are you going to work for me? Yeah, I think so. Where am I? Here. So if I let x equal -1, that's -12 equals -4b. So b is 3. And if I let x equal 3, then I get 15 minus 7 is 8 equals 4a plus 0. So a is 2, the same things I just got. Either way. Which tells me that 5x minus 7 blah, blah, equals 2 over x minus 3 plus 3 over x plus 1. So what is this equal? It equals 1 plus 2 over x minus 3 plus 3 over x plus 4. Maybe? So we broke the 1 out, and then we took this, worked with it, broke it out. So again, if the degree is not smaller on the top than on the bottom, don't do partial fractions yet. You have to first divide it. So you can really work on the part that's fractional. Get the whole part out of the way. Partial fractions will not work if it's anything except bottom heavy, right? The bottom degree's got to be bigger. Is everybody with me a little bit? Not at all? Screw you, Jeff. Okay. All right, so let's do the next. Here we go. There's always another level. So can I erase all this? Is everybody ready? Can you erase all this? I'm gonna start and see what happens. Okay. Oh yeah. So look here. 2 over x plus 4 plus 3 over x plus 4 squared. Go ahead. So we're kind of doing backwards, right? This is not what chapter 11 is going to have. This is from before. Can you guys take a minute and combine these two things? This one should be relatively quick. All right, this one has to be quick, right? What's the only thing that's missing something? Hopefully nobody gave both of them something because only one of them is missing something. Which one?
The first one.
First one, yeah. First one's missing an x plus 4, right? He's like all jealous. You got 2 of them? I only got 1 of them. All right, let me get one. All right. So now they both have x plus 4 squared. So this is 2x plus 8 plus 3 is 2x plus 11 over x plus 4 squared. All right, now let me ask you this also. Will anybody freak out if I say, all right, the original bottom here, that's obviously linear. Do you guys agree with me? This is linear, yes? Linear meaning all the variables are to a first power. Okay, I'm going to assume that's a yes. That is also linear. It's just got multiplicity 2. Does everybody understand what I mean by that? I mean, if you multiply it out, it becomes not linear, correct? But isn't this a linear multiplicity 2? Is that all right? Do you guys understand? This is important. This isn't just me going on the side with shit. This is important. Okay. So that's going to come back in a minute. What have we just determined? If I have something that looks like this, where the bottom is a repeated linear function. Right? So if I had something like this, 5x minus 6 over x minus 3 squared. What am I going to put over here? Where could this have come from? Something over what plus something over what? You could do it.
X minus 3.
Yeah, there could have been a part with just 1x minus 3, like we had 1x plus 4, and then another part that has x minus 3 squared. So I want you to start to realize, okay, stay with me now, stay with me. This is where things get more complicated. When the bottoms get worse, the procedure gets a little more complicated. Of course it does. But this is the main thing. Whatever you put on the top, stay with me, has to be 1 degree below what's on the bottom. This is linear, that's a constant. This is linear, there's just 2 of them, but still linear, that's a constant. I don't know if you guys are, I'm trying to give you a way to remember this. Okay, all right, so now you just do like you always would. What would I do next? Here, let me put this up here so I got more room. Have a thing. Have a thing. Equals a 3 plus. All right, so what's the next step? Sorry. Nobody can tell me? Nobody can help me? You should know, math boy. No, I know. I do know. I'm asking you. What's the next step? What did we do every time with the other problems we did? Multiply. Yes, multiply by the bottom. So let me just kind of do this. If I multiply by x minus 3 squared everywhere, this gets a little bit weirder. That cancels. One of these x minus 3's cancel, but then you get a times x minus 3. And then you have plus b all by itself. Now that looks a little more like that very first example I showed you, right? So this one, I don't know. I mean, what's beautiful about this one, it's actually pretty quick. What must A be? What's A got to be? What's the only thing A could be? What does A have to be?
5.
A's got to be freaking 5. Done. Yay. And then -3 times A plus B has to be what? What does this have to equal?
Minus 6.
It's got to equal -6, correct? Just because it's in the right place for it. Now, why did I write it? So this has to be -6, but I already know that A is 5. So add 15, B is 9. Ooh, I made a nice one. I didn't even do it on purpose. So what did we just figure out? Oh, this is beautiful. I love it. I'm sorry. I wish I could say I did this on purpose. We just figured out that 5x minus this equals 5 over x minus 3 plus 9 over x minus 3 squared. Okay. All right. Now, let me see if I could push this a little bit. I'm going to show you something that, well, I'm just going to show it to you. And we'll see if it ever becomes something you try to do. This is a really weird little side note. This is exceptionally weird, okay? Let me see, 5x minus 6 over x minus 3 squared. All right. What if I put 5x minus 15 plus 9? Now, why would is anybody think that is this something different from this? Are those the same? I'm claiming they're the same. Are they the same?
Sure.
And okay, so they're the same, right? I could have put -4, -2. I could have put -3, -3. I mean, anything that makes -6, Jeff. But why did I put this? Because doesn't this have x minus 3 in it? All right, this is really, really weird. I'm just going to show it to you, and then you can forget about it forever if you want to. Isn't this 5 times x minus 3 over x minus 3 squared plus 9 over x minus 3 squared? Doesn't one of those cancel? And isn't that what we got? Isn't that the answer we got? Isn't that the answer we got? Wasn't that the quickest? Is it always easy to say no? No. All right. So the quickest ways always require the most understanding. Always. Okay, so now I've shown you 3 ways. 2 of them are good. The third way is a little freaky, but I just wanted to throw it out there. If you have no idea what I did here, you're fine. You're completely fine. All right. Next level. You guys ready? Sorry, I'm shouting at you. I don't know why. Next level. I'm going to erase all this again. Here it goes. Fast and furious coming at you. Here it goes. Okay. No Jason Statham. No. No The Rock. No. So what about, all right, what about this? Let's see, Jeff. Yeah, sure. All right, let's make this gross. 4x squared minus 2x plus 3 over x cubed plus 8. Chumbawamba. Oh, this is nice. So a quick check. How do I know I can start attacking this with partial fractions methods? What's true about this that tells me I can do that right away? The bottom has a larger degree. I like it. Yes, the bottom has a larger degree than the top. I don't have to long divide, thank God, because it wouldn't get me anywhere. Okay. Can somebody factor the bottom for me, please?
X plus 2.
X plus 2. What about x plus 2? What do you mean? Sorry?
Wait, yeah.
It's a good
X
start.
plus 2 3 times?
No. I want to really think about that. If it was this, sure you get x cubed and you get 8, but don't you get 2x, 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 to x squared, 4x squared? No. Fudge. Don't you get a lot of other shit besides x cubed and 8? Nothing's going to cancel, correct? Are you with me? Does somebody else remember? How much have I talked about cubes factoring with you guys? I'm pretty sure we did it way earlier this semester, didn't we? Did I tell you how Pulp Fiction works into the method of factoring? Anybody? Has anybody ever seen the movie Pulp Fiction? Anybody? Nobody? None of you? All right, I should make this homework. Okay, Austin says, of course, but I don't know, Austin. I have, thank you. I thought for sure I did. So what this other guy is going to be, it's going to be 3 parts to him.
X squared.
Yeah, I've got 1x, so the other 2 have to be there. I've got 1, 2, so I've got to have a positive 4 there, so I get my 8, right? And then the middle term is the cleanup guys, the wolf. The guy comes out there and sprays all the blood off and shit, right? Okay. So does this make sense so far? 1x, 2 x's, I get 3 altogether. 1, 2, 2 2's, I get 3 2's altogether. But don't I also get plus 2x squared? And don't I also get plus 4x? Yes. Do I want those? Are those a part of my answer? No. I want to kill them. I want them to die. So the way, wow, the way to do that, the way to make sure that they die is I have to have an opposite sign here. That makes sense. Minus. And then what's amazing is you just take whatever this is times whatever that is. So let's check this out. Didn't I get a 2x squared here that I didn't want? Isn't this negative 2x squared? Do you see that? This 2x squared and this negative 2x squared cancel. Didn't I get a 4x that I don't want? Isn't this negative 4x here? They would kill each other, yes? No? Maybe? Okay, I'm just gonna keep going. All right. I'm pretty sure, didn't I put a factoring methods worksheet up on Canvas a million years ago? Or like 1,000,007 years ago? No, you're fine, you're fine. Don't say that. This is not something we do a lot. We do not factor cubes a lot. So you're fine if you forgot. Yes, I did. Okay, good. So it's up there. There is a factoring methods handout up there. This will become kind of important in this section because the first step is factor. Now, what's kind of wrong with this? Is there a repeated thing like that last one we had where it was x minus 4, I think it was cubed, whatever the hell it was, where it was not cubed, where it was something repeated? Is that what's happening here? No. This is linear and this is quadratic, correct? This is not something repeated. I can't factor this to be like this. It's not a multiplicity, is it? You guys with me on that? So this is different. And what did I say about the top? So I know that this is going to be x plus 2, and I know that this one has to be this business. I know it is. That's how it's always worked. This is what's called an irreducible. Can I spell irreducible? I think that's close. Irreducible quadratic. So what goes on top of this is a constant because that's 1 degree below what's here. So what has to go up here? What's the bottom degree? 2. It's the second degree. So what's got to go on the top? Linear. So the top has got to be, you got to be shitting me, Jeff. No, I'm not. No. So the top has got to always be exactly 1 degree below the bottom. This is truly second degree. It's not just the multiplicity of the linear or something. This is truly second degree. So the top has got to be a linear thing. And how many parts can a linear thing have? 2. Ah, shit. It gives me 2 freaking variables. Damn you, you stupid little thing. All right. So now I'm going to multiply by these. And I can do this the kind of quick way, right? Is that all right? If I multiply by this and this, these of course cancel here. The x plus 2's will cancel, so the a picks this up. Right, if I wrote this next to this, the x plus 2 would cancel, so this is still there. The opposite thing happens there. Bx plus c picks up in x plus 2. All right, let me stop for a minute. The only new thing up here compared to what we did before is this stuff. That's it. The next thing I did is exactly the same thing we did before every time. Now, do you want to set up a system of equations? You could, right? Couldn't I multiply this through? And then, like, for example, ax squared, and this is going to be bx squared. So a plus b would have to equal 4. Are you guys with me? The minute I get more than 2 letters over there, I'm going to try to do that x, let x be something thing until it doesn't work. You don't have to. Maybe I'll do this both ways. What time we got? All right, maybe I'll do this both ways and that'll be it. Can somebody see what a good value of x would be to let x equal? Right? There's a really good value that's going to kill 2 letters in one go. What would make that 0? -2. So if you let x equal -2, let's see what we get here. -2 squared is 4 times 4 is 16. Plus 4 is 20 plus 3. I get 23 here if x is -2. And then here I get 4 plus 4 is 8 plus 4 is 12. And of course, that's all 0. So I get A is this beautiful 23 twelfths. Oh, A, you suck. I don't know if you guys are going to like this next part. All right. Anyway, so let me see. I don't have much room here. And I think I'm losing you guys. Now here's the key. This is what I meant by this doesn't always work. Can somebody tell me a value of x that'll make this 0? No, stop trying. You can. You'd have to use quadratic formula, and you're going to get, yes, you would get complex numbers. Screw that shit. So what I'm going to do instead is I'm going to go ahead. See, I already know what A is. So now let's see if I can kind of, well, let's see, ax squared minus 2ax plus 4a. All right, let's see if you guys trust me over here. Plus bx squared plus 2bx plus cx. So plus 2b plus cx plus 2c. Oh my God. All right. So what must a plus b be? What must a plus b be? They're the only things in front of x squared, correct? So what must a plus b be? If it's supposed to equal this, and a and b are the only things in front of x squared, what must a, sorry?
4.
Yeah, it has to be 4. Do you guys still get that? That doesn't change. Man, does that know from before? I don't know, right? Because the numbers in front of the x squared have to equal the number in front of the x squared. It's got to be. So a plus b has to be 4. But don't we know what a is? We know a is 23 twelfths. So b is 4 minus 23 twelfths. So b is 48 twelfths minus 23 twelfths is 25 twelfths. Oh my God. Don't we already know what, does somebody see that we already know what C is? What's beautiful about C? Well, no, we don't. I didn't realize this number. Where's everything that doesn't have an X attached? Right here and right here, correct? So what must 4a plus 2c equal? They do not have an X attached. So what must they equal?
3.
They have to equal 3. It's the only thing that doesn't have an X attached. I like it. But don't we know what A is? A is 23 twelfths times 4. Let's see. Are you guys cool with this? 4 times divided by 12, so 23 thirds. Is that all right? 23 thirds plus 2c is 3. So 2c is 3 minus 23 thirds is 9 minus 23 thirds is negative 14 thirds. And then if I divide by 2, I get negative 7 thirds. Okay, that got really gross at the end, and I'm sorry. So now all I have to do is put the A, put the B, put the C, done. I've got it broken down as much as I can. Oh my God, that was gross. So let me. Let me make this thing active on Canvas. Let me keep my big old head out the way. All right. If I go to Canvas, come on, here we go. I do have a handout. If you go to chapter 11, unit 11, you will now see a partial fractions handout. All right, anybody still copying down from the board? You're going to hate me in a minute, but too bad. There we go. If you go to unit 11, partial fractions. Do you remember where we started? Wasn't that good times? Oh, so nice. And I even have the alternate method here, right? And then I have a repeated linear factor, right? So that's why the top has got to be a constant because the bottom is actually linear. Then I have the irreducible quadratic. Oh, this is the one like we just did. See there? It's got a linear on top. And then we have repeated irreducible. Oh, shit. Where I have an irreducible to a second power, which means every time I have something repeated, I need one thing with the first power on the bottom and another thing with the second. So if this was a third power, I would have to have one more plus and one more thing that looks just like this over this to the third power. So that's how every time there's something repeated, that's how it works. Damn, Jeff, that's a lot of shit. I know. All right. I don't know. Are you guys tired of me doing things like that? I'm sorry. It's not going to stop. All right. Let me stop sharing so you guys can finish copying if anybody is. All right. And let me want to have a little bit of a preview of where we're headed. Somebody still copying from the board? Are you guys good? Okay. So where we're headed, let's see if you guys, now listen, I think a few of you guys said that you've heard of matrices and they make you kind of feel nauseous or something. I'm kind of paraphrasing. Is that true? Anybody heard of matrices? Matrices. So this is what they look like. And I want you to realize they should kind of look like the next level of vector, right? Oh, let me see, somebody's chatting at me. Aren't they common? Hell yeah. Excel spreadsheets are built on matrix algebra, right? Excel spreadsheets are built on matrix algebra, obviously. Doesn't this look like, if you ever use Excel, this is like somebody just copied numbers out of an Excel spreadsheet. But look at this, like the 1, 2, isn't that a vector? Can that be a vector 1, 2? And then it's kind of married with the vector 3, 4? Yes, maybe? No? So vectors are sort of like building blocks for these matrices. Do we necessarily have to look at it like that? Not at the beginning. No, so don't freak out, right? Matrices are their own thing. They exist. But what we're going to do with them, well, the very first thing we're going to do is we're going to discuss the parts of it, how to identify different parts of it. Then we're going to start to see how do two matrices add, how do they subtract. What gets really weird is how do they multiply. Multiplication gets weird. How do you hope that these two add together? How would you hope that these two would act if you're going to add these together? Considering that they are basically vectors kind of like stacked on top of themselves. All right, who remembers? How do you add two vectors? So if I have vector 1, 4, and I have another vector 2, 3. How do I add those?
One plus two, comma.
Yeah, okay. So how do you think that if I'm going to add these things? Shouldn't it just be 2 plus 3 is 5? Yes? Don't you wish it would be that? Don't you just wish it would be that? Well, in reality, that's exactly what the shit it is, right? So 6 minus 2 is 4. 1 plus 1 is 2. 0 plus 5 is 5. 1 minus 4, -3. -3 plus 3 is 0. Who's chatting at me? That is nice. Isn't that nice? That is so nice. Why does it work that way? Because like I said, matrices are basically higher level vectors. They're like a collection of vectors. I can actually think of them as like a collection of 3 two-dimensional vectors. Are you guys with me? Do you see how that's a collection of 3 two-dimensional vectors? No? No? Play with me, guys. Either say, I know what you're saying, or say, what the shit are you talking about? Isn't this like the vector 2, 6 stacked with the vector 1, 0 stacked with the vector 1, -3? Yes? Okay. I'm going to assume that's a yes. Okay. Or I could look at it as 2 vectors. The vector 2, 1, 1. So a 3-dimensional vector with the vector 6, 0, -3. And depending on what you want to do with it, both of those are correct. Right? So the interpretation depends on what you're going to do with it. They actually work either way you want to look at it. All right, so that is why addition subtraction is so simple. But somebody remind me, is vector multiplication like immediately obvious? And did we even talk about all the ways to multiply 2 vectors? So is vector multiplication simple? The way that we did it, it's simple, but it's not like immediately obvious, correct? Do you guys remember how to multiply 2 vectors? What would these multiply to be? Let's see who remembers. Dot product. Dot product, go! Let me remind you one thing. The answer should be a number, not a vector. Does anyone remember?
It's around 20.
1 times 2 is 2, plus 4 times 3 is 12. Remember, because the I and the I. So when you do 1 times 2, the I dot I becomes 1. When you do 1 times 3, that's I dot J. That becomes 0 because they're perpendicular. So that's why dot product, when they're written like this, the dot product is stupid easy, right? It's just component times component added to component times component. But there's a whole other way to multiply that I didn't even talk about. I think I told you the name of it is cross multiplication, but we didn't even talk about it. So matrix, if I wanted to multiply, I'll tell you this right now, I could not multiply these together. These are 2 matrices I cannot multiply together. So matrix multiplication is a little weird. And just to kind of, let me see, one more thing, one last thing, and then I'll let you guys out, okay? I think you guys are starting to look a little cross-eyed. Let me see if they give me an example. Give me an example I want. Give me an example I want. No, I don't want any of those examples. There we go. No, screw it. You guys suck. You all suck. You suck. All right, let me give myself an example. Sorry. Real quick, this is it. This is the last thing. If I was going to add this matrix to this matrix, what's your gut tell you about if that should be possible? If I try to start doing this, 2 plus 3, 1 minus 1, 3 plus 0, 4 plus 2, void, empty space, plus 1, emptiness, plus 4, what the shit? So this cannot be done. So we will learn that to add them or subtract them, matrices have to have the same dimensions. So this is what's called a 2 by 2. Is everybody, do you guys see that? Isn't this 2 rows and 2 columns? So I'm going to call it a 2 by 2. And this is 3 rows and 2 columns. So I'm going to call it a 3 by 2. So are they the same size? No. Can you add them or subtract them? Hell no. All right, that I think is enough. I've thrown enough at you. So tomorrow, not tomorrow, Monday. Don't come to class tomorrow night. Monday, we'll get into, it'll be devoted to matrix stuff. And of course, the first thing we'll devote to is any questions you guys have. Because of course, Monday is the quiz. And while I'm saying this, let me unlock the quiz, the solutions to the practice quiz. I'll go ahead and unlock that now. So you got plenty of time to look that over if you want to. And otherwise, class is over. So you can head out if you want to. If you have a question, let me know. What's going to be on the final? So what could be on the final is everything we've talked about this entire semester. Will I give you a practice final? Yes, I will give you a practice final. There will be a solutions to it. But every math course is supposed to have a cumulative final. The final is supposed to be everything because we're evil. Or there's some other reason, I don't know. So now the solutions video for the last quiz is active. So you can go see that. And like I said, I do have a practice final. It's going to have a solutions for it too. Yeah, something to look forward to, right? Can't wait for that. It's going to be a lot of fun, that final. It's going to be a lot of fun. All right. Anybody else? You guys have any questions or are you guys good?
Thank you.
You're welcome.